Good afternoon. JNV Pune has joined.
Wait, good morning.
Okay. So let's start with the recall test. What we have learned is summarized in these 6 statements. So you need to choose incorrect statement or statements. It may be one, maybe two, maybe three, different number of states. You can answer in the chat only. So study them and answer them. Okay. Okay, so there are few statements mentioned here. What you need to do, you need to answer the incorrect statements. So I am waiting in the chat box. If anyone got it, then he can answer. First statement says, work done by the conservative forces depends only on path followed. Okay, so have you remembered that work done by conservative force depends on path or depends on initial and final position? What can you say? Do you need more time or whatever? You can chat me, you can answer in the chat box. Be proactive. Again, I'm repeating this thing. Be proactive and answer quickly. This is the mandatory thing. Okay, let me ask individually whether first statement is true or false. Work done by conservative force depends only on path followed. What we have told you, the work done by conservative force depends only on initial and final position, not on the path followed. So first statement is incorrect. Incorrect means false. So statement A is false. Second statement is work done by friction in a round trip will not be zero. So first of all, we need to know whether friction is a conservative or non-conservative force. I have told you friction is a non-conservative force. Friction is a non-conservative force. For a non-conservative force, work done in a round trip is not zero. Work done in a round trip is not zero. So statement B is true. I think these 2 points are clear. Third statement is work done by gravity is equals to the change in kinetic energy. Whenever you see the change in kinetic energy, what you need to remember is the total work done is equals to change in kinetic energy. Here they are saying only work done by gravity. They have mentioned a special force work done by gravity. So what we have learned, work done by all the forces, and total work done is equals to change in kinetic energy. This is the work energy theorem. So the statement is again wrong. This is partially, you can say it's correct partially, but overall this statement is wrong. So again, C is false. Fourth statement is very interesting. I need all of you to answer. Work done by normal reaction is always zero. Work done by normal reaction is always zero, whether it's true or false. When I see a word always zero, it seems that we need to check all the possibilities here. We need to check all the possibilities here. So in some situations, okay, JNV Raigad has joined the session. Work done by normal reaction is always zero. What we need to do, we are doing a recall test of the previous sessions, and there are some statements mentioned here. You need to identify the wrong statement in this. JNV Rajkot is also there. Okay. So we are on the fourth statement. I can show you a situation. For example, a block is placed on a surface, and I am saying that normal reaction will be something like that. And the situation is the whole setup is moving upward. Someone is carrying it on his head and going upward direction. So in that situation, displacement is also upward and the normal reaction is also upward. So the work will not be zero. That we have seen in some situations, that work done by normal force, normal reaction is zero. But this is not the case always. It depends on the angle between force and displacement. In this situation, I have described in the board, the normal reaction is upward and displacement is also upward. If someone is carrying it upward direction, then work done is not zero. So the statement work done by normal reaction is always zero is again a false statement. It's an incorrect statement. Again, next part is area under the force displacement curve gives work done by the force. I need your answers here for this particular question, for this particular statement, whether it's true or false. You can write very quickly if you have remembered anything from the past classes. Okay, someone has answered true. JNV Raigad says true. Anyone else? Very good, JNV Raigad. Area under the force. This is a clear-cut statement that I have told you. This is a true statement. Again, next statement is work done by the spring force is always negative. Work done by the spring force is always negative. What can you say about that? Someone answered. Okay, JNV Raigad is again very active. He says false. Okay, very good. That's the again clear-cut statement that I have mentioned. Work done by spring force may be positive, may be negative, and that's why always negative is false, and this statement is false. So how many options are false here? You need to identify the incorrect statements. So A is false, C is false, D is incorrect, and F is incorrect. These four statements were wrong. Four are false. Very good. That's the way you all should answer. Very good. I think this much is clear. All the concepts we have done, I have revised all of them. Now, in the previous class, we were discussing the work energy theorem. So let's start. Let's begin with there. Okay. So here is a question on your screen. A simple question. The situation says that this is a fixed support and there is a hook and a string is attached with this hook with a ball of mass m. The situation you are getting, from a hook, a string is attached and at the end of the string there is a ball and the string is kept like that. What they say, calculate velocity of the ball at the lowest point. At the lowest point of its path if it is released from point A. If we release it from point A, then what will be the lowest point? It will go like that. It will go like that now. Then the lowest point is something here. What you need to do, you need to find the velocity at the lowest point. Can you tell me one thing, that at the lowest point, its velocity will be something here, like that? Let this velocity is v. At the point A, it was released. If it was released, then its initial velocity is 0. You can say that. Released and initial velocity is 0. So what I want to do, I need to find this velocity. And this length of the string is L. Length of the string is L. It's given. Okay. You have 1 minute of time. I have explained the question. Just do some calculations and answer. Okay. You are trying, I hope so. And you will tell me in the chat box if your answer was correct or incorrect. Okay. Okay, someone has answered. Okay, the question I will repeat, definitely repeat. The question says the situation is like that. There is a ceiling and a string is like that. At the end of the string, there is a ball of mass m attached. The string was in this position initially. And I have released it from this position. And when I release it, it will go something like that. And they asked us to find the velocity of the ball at this lowest point. It will go like that now. So they asked me or asked us to calculate the velocity at the lowest point. Let the lowest point is B. So they have asked the velocity at the point B. That's what we need to do. Okay. What I say, from work energy theorem, total work done is equals to change in kinetic energy. This is our initial position and this is our final position. Identify the forces here. On the ball, there is a tension and there is a gravity. Only two forces are there on the string. Okay, zero. Someone says zero. JNV Raigad says zero. Okay, let us check. Can you, JNV Raigad, can you imagine the situation if you practically think about it? Just don't go about mathematics, don't go about physics, just use some basic phenomena that you know, that you can see in your real life. If you release the ball, something like that, and it will go. Can you imagine that it will stop at the lowest point? Can it stop at the point B? If you release the ball at some height, then can it stop at point B or it will go further? If your answer is it can't stop at point B, then this velocity cannot be zero, because until it has some velocity, it will go again and again further. So you can imagine it. It will go further. Very good. It will go further, then its velocity cannot be zero, na? So that's what we need to calculate. So work done total is equals to change in kinetic energy. Total means two work done are there, tension and gravity. What I have told you, if this ball is moving this way, then during its path, tension is always perpendicular. Tension is always perpendicular, so I will write work done by tension plus work done by gravity is equals to change in kinetic energy. Work done by tension will be zero. Work done by gravity is mg, and the parallel displacement that I have told you, parallel displacement, ball is moving from A to B. The displacement in the y direction is L. Then work done is mgl. Gravity is downward, displacement is downward. That work done is mgl is equals to K final is half m v square minus K initial is what? Initial velocity is what? Zero. Zero. Then final velocity will be m gets cancelled. V is equals to 2 is there, 2gl, and v square is this, then v is root 2gl. This is what we have got as the answer. The answer is root 2gl. The concept is clear in your mind now. Again, I have used the concept of conservative forces. Conservative forces, work done depends on the initial and final position. So work done by gravity can be calculated very simply by mg force and the displacement parallel, which is L. If you have any doubts, you can ask. Otherwise, I'm moving ahead. Okay. We are moving further. Okay. Okay, sir. Go further. Very good. Again, there is a simple question on your screen. Try to learn things from these questions. I am not saying that these questions are the only questions that you will face in the examinations, but the concept is building. After that, I will provide a sheet of the questions from where you can practice and you can ask the problems that left behind. So we are not going in lot of questions, but clear the concept from here. The question says, there is a block of mass m and the surface is smooth, and this is moving with a velocity v naught along the horizontal path, and there is a spring constant k. Find the maximum compression in the spring. Find the maximum compression in the spring. Again, this is a simple question. Let me clear one thing. Whenever you see questions related to velocity, kinetic energy, and compression in the spring or elongation in the spring, always try to find a way to apply conservation of mechanical energy theorem or work energy theorem. These two theorems will work there and you will easily get the answer. There are various ways to solve these questions, but the best approach is to apply work energy theorem or conservation of mechanical energy theorem, which we are going to study in the later section. So from here, work energy theorem. First of all, when you apply the work energy theorem, you need to decide the initial condition or initial position and the final condition of the diagram. So this diagram is in the initial state. Finally, it will look something like that. The block will move ahead and stick to the spring and will compress it. So the diagram may be looking like this is the final situation that is going to happen. Block will compress the spring now. So in that way, can you see that spring was initially here and it got compressed by a distance x. Let's assume this distance is x. The compression is x. Again, what I can say, work done total is equals to K final minus K initial. Okay. What is the meaning of maximum compression? The maximum compression means after that point, spring will not compress. So you need to answer one thing. If spring is not going to compress, then what will happen? Spring is just compressed. And after a certain point, it's not going to elongate. So it's not going to compress actually. So it will pull the block outward. It will pull the block outward. So at this point, what is the velocity of the block? You need to answer. At this final position, the maximum compression position, what is the velocity of the block? Can anyone answer? Okay. JNV Pune, Raigad, Rajkot, and one is class 11th. All these students need to answer. This is a very simple question that I have asked. I am not asking about the numerical. I am asking about the velocity of the block at the position of maximum compression. Okay. Okay, someone has answered 0. JNV Rajkot says 0. Very good. This is the same situation now. If I throw a ball upward direction, then at the maximum height, its velocity becomes 0. Maximum means the maximum height that it can achieve. That means its velocity is 0. So in the same way, its velocity at final position is 0. So work done total. Can you say that work done is done by the spring? Spring is getting compressed now. So work is done by the spring. And spring's work done is, what you say? Work done by the spring force is half kx square. That was the magnitude I have told you. That is half kx square. We need to choose the sign accordingly. Block is going in this direction. Block is going in this direction. And spring force will be in this direction. So there is a opposite direction of displacement and force. So the work done will be negative, is equals to final kinetic energy is 0 minus initial kinetic energy is half m and initial velocity is v0 square. So minus got cancelled. V0 is, this 2 also get cancelled. V0 square is K by M x square. Okay. What we are asked, they are maximum compression. So they asked us the maximum compression. So x is equals to M by K V naught under root. This is again a simple conceptual question. How to find the maximum compression, how to find the velocities. These are the questions that are very frequently asked. Is it clear to you? Okay, so I am moving ahead. Potential energy. This is again a very good conceptual term. Potential energy. Okay, listen to me now very carefully. What I have told you. I have told you in the first session itself that work done is a method to transfer energy. Is it clear now? Work done is a method to transfer energy. So now I am putting a situation in front of you. And this is very important situation to be noticed. Suppose this is your ground. And ground, there is a block of mass M kept at rest. And this is some height. This is something your terrace, your first floor. A person came, lifted this block on his hand and moving very slowly in the upward direction and kept the block on the terrace. He is moving very slowly that at any instant of its path from ground to the terrace, the velocity of the block is zero. He is moving very slowly. The velocity of the block at any instant is zero. We are assuming this line. So actually he has done some work. If this height is h, he has done some work. And you can easily calculate that work, how much work is done by the man in putting this block from ground to the terrace. And I have told you, or physics has told us, that work done is a method to transfer energy. Mechanical work will transfer energy in the form of mechanical energy. If you see the situation, here the block was at rest. Here the block is again at rest. We have done some work and the work is not visible in the form of kinetic energy. Work is not visible in the form of kinetic energy. Then where did it go? Then where did it go? Are you getting my point? What we have seen earlier, for example, if the block is kept here and a person pushes the block, applies a force, then its kinetic energy increases now. Slowly, its kinetic energy increases. But now in this case, I am saying it was initially at rest, finally at rest. So where did the work go? The answer is this work has increases the ability of the block. Listen to my words very carefully. This work, the work done by this man, has increased the ability of the block to change its kinetic energy. How? Just let me complete it. If I release the block from this height, I have taken the block to the height h from the ground. And if I release it from there, what will happen? It will go and its kinetic energy will increase till the ground. So what I'm saying that this work done has increases the ability of the block to increase its kinetic energy. whenever the situation came. So the potential energy is ability. Potential is what we generally say, na, he doesn't have the potential to play in this 11 members team. Like if in cricket we generally use to say that this particular player has no potential, or this particular player like Sanju Samson has a lot of potential but he is not getting the chances. So potential is what? Potential is the ability. So potential energy what potential energy is the ability of something to do, and what to do is to increase its own kinetic energy. That's what potential energy is. So in physics, how we define the potential energy, that's on your screen. The energy stored in a body due to its position in a system of bodies. If I clear some of the portions so that you can see. Okay. So what is potential energy? The energy stored in a body due to its position in a system of bodies. Now again, I am explaining this term to you. What if I say Earth is not there? What if I say that Earth is not present? Then what amount of work you need to do to put this block in the upward direction? You need not to work, because there is no gravity acting in this case. Very good, 0. So if I say that work done here is mgh, and this work is stored in the form of potential energy, then it simply means that the potential energy is arising with the presence of Earth, Good afternoon, very good. Good afternoon, JNV Sangli. So potential energy is arising due to the first thing is due to the work done. Second thing is due to the presence of Earth in this particular question. So this Earth is the system of bodies. One system contains Earth and the block as a system. So our system has block plus Earth. This system has the potential energy. Now I will summarize all the things on the next slide. You need to remember all those things that I am going to explain on the next slide. Okay. First thing. Now the crux of the explanation is the work done. WD is the work done by against the conservative force is stored in the form of potential energy. Now, the first statement is work done against the conservative force is stored in the form of potential energy. The condition is that given that no acceleration is produced. Now, let me tell you one thing. Let me explain it. There are so many examples. If you do a work against the conservative force, then this work will be stored in the form of potential energy. For example, I am lifting this pen. I am lifting this pen and I am lifting it against the conservative forces. Conservative force is what? Gravitational force. I am lifting it against the conservative force. Then this work done will store in the form of potential energy. One thing. Again, second thing. Second conservative force, you know, is the spring force. If I compress the spring, then I am doing a work against the conservative force. And this work is stored in the form of potential energy. Again, what if I release it? Then it will again convert into the kinetic energy. What if I release this pen from this height? It will again convert to kinetic energy. Another example, another conservative force that you have studied is electrostatic force. That is force between two charges. I have two charges. One is positive, one is negative. You all know that they will attract each other. You all know that one is positive, one is negative, they will attract each other. I have moved them away like this way. I have pulled them apart and placed them here. So in doing so, I have put some work, and this work is stored as a potential energy, in which in both the particles, as in a system, and system contains what? Two particles. So this work is stored. If I release one of them or two of them, then these charges will again move towards each other. So the potential energy is again converting to kinetic energy. The work done against the conservative force is stored in the form of potential energy, and the potential energy is known as gravitational potential energy if the work is done against the gravity. The electric potential energy if the work is done against the electrostatic force. The elastic potential energy if the work is done against the spring forces. So are you getting these points? I have told you three names: electric potential energy, gravitational potential energy, and the elastic potential energy. Have you got the concept here? Okay. If I move this ball upward, then the work done against the gravity is stored in the form of potential energy. If I compress a spring, I compress it, then I am doing work against what? Spring force. And spring force, if I release it after compression, for example, if I have compressed it till this position, and if I release it, then this block is again moving forward. This is what? Conversion of potential into kinetic energy. And the third situation, I have told you that there is a positive charge, there is a negative charge. I have moved this charge away. In doing so, I need to do some work, and this work gets stored in the form of potential energy. If I release it, they will again try to move towards each other. So in all these situations, how to identify the type of potential energy? If work is done against gravity, this is known as gravitational potential energy. If work is done against the spring force, this is known as elastic potential energy. If work is done against the electric forces, this is known as electric potential energy. These are the things that you need to remember. First thing. Second thing that I need to emphasize on: potential energy is defined for a system. Now, what is the system? How to identify the system? If I remove this earth, can there be any work possible? You will say no. So the gravitational potential energy is defined for what? Is defined for two masses. At least two masses must be there to define the gravitational potential energy. One in this particular question is earth. Other is the ball of mass m. In this situation, One body is the block and other body is the spring. In this situation, these two charges are the system. So potential energy is defined for these two charges. So potential energy is defined for a system, and potential energy is the work done against the conservative forces. These two things you need to remember. Note it down. Moving further, if I ask you what this potential energy can do, you will answer me straight away that potential energy can increase the kinetic energy. Once the situation arrives, if you release it, then its kinetic energy will increase. That's the answer. Simply answer is, again, gravitational potential energy. That I have told you, there is no need to mention that. I think there is no need to mention that work done is equals to change in potential energy. That's what I have told you now. That work done against the conservative force is equals to kinetic is equals to potential energy. So that's what I have written. Potential energy is denoted by U, and delta U is the change in potential energy. That's what. And I think you all know that potential energy is mgh. I hope you all know that. Potential energy is what? Gravitational potential energy is what? mgh. There is a simple derivation of that. I don't think it's important for us to do. So what we have learned, gravitational potential energy is what? mgh. Again, I think you can ask if you want to ask something. Now the term came in according to your syllabus is elastic potential energy. So what is elastic potential energy? Elastic potential energy, do you know the name? I have told you again. The potential energy of the spring. The potential energy of the spring. Again, let's say, what if I just tell you the formula of the potential elastic potential energy? There is nothing important in the derivation. Elastic potential energy of the spring is half k x square. And I think you all know that work done by the spring force is what? Half kx square. So work done against the spring force is known as elastic potential energy. So that's where it came. So it's not a new kind of derivation. This is actually the work done by the spring force. So it has came out to be half kx square. So you need to remember two parameters here. One is gravitational potential energy, which is mgh. Second is elastic potential energy, that is the potential energy of the spring. Potential energy of spring. This is half kx square. So after remembering these two things, I will tell you one more thing. And that one thing is again very important. And I hope that will be well understood. Have you studied the chapter kinematics? And there is one thing, frame of reference. Frame of reference. Say yes or no whether you studied it or not. Just say yes or no. Studying. Okay, studying means you are on frame of reference right now, or what? Have you studied it now? Frame of reference. The basic concept of frame of reference was you can choose your frame as per your question. You can choose your frame as per your question. In the same way, Navodaya school to everyone. No, sir. Okay. Okay. Let me tell you again that frame of reference is the position from where you are observing the motion. Is the position from where you are observing the motion. So what I say, in case of gravitational potential energy, you can choose the reference level as per the question. And this can be best explained by the numericals. What I'm saying, choose the reference level as per the question. As how you choose the reference level in the kinematics, you can choose the reference level in the questions as well. For what? For the potential energy. And what I mean with the reference level, you can choose the reference level, means at the reference level, you can choose u equals to 0. You can decide in the question that at which point, at which place you are going to take the reference level. Don't panic. Everything will be cleared in the numerical section. In the next slide, in the next slide, you will get everything clear. But now we have to remember is reference level can be chosen according to the question. That's it. Okay. Conservation of mechanical energy theorem. This is again the most important. Write it, most important. Okay. Again, a simple statement. Mechanical energy is what? Kinetic energy plus potential energy. And they will be conserved if, so I will write mechanical energy of a system will be conserved if, first point. Have you remembered the point that in the presence of conservative force, I have told you the definition of conservative forces, that in the presence of conservative forces, mechanical energy cannot be converted to internal energy. That means mechanical energy remains conserved. So what the first point is, there should be no non-conservative forces. There should be no non-conservative forces. If there is no non-conservative forces, then mechanical energy of a system is conserved. And what does it mean, conserved? Conserved means mechanical energy initial is equals to mechanical energy final. What is mechanical energy initial? Is kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. This is the simple statement of conservation of mechanical energy. What does it signify? If there is no work done by the non-conservative forces in a system, or you can simply say that if no non-conservative force is present, then mechanical energy remains conserved. What is the mechanical energy? Kinetic energy plus potential energy, and the sum of which is conserved. This is kinetic energy, initial kinetic energy, potential energy initial, kinetic final, potential final, and the sum of which is conserved. That's what is the case. And I hope its time is moving further. So we will wrap these things. I will start from here tomorrow with the simple questions. So I hope you will join. And tomorrow session is going to be very important. All these concepts will be cleared in the tomorrow session. And remember the timings. Till then, bye.